Okay, well, I'm going to get us started. As usual, people will probably be trickling in over the next few minutes. Welcome back to our wildfire seminar series for winter quarter. I'm glad to have you here. For those of you who are interested, or maybe have colleagues who are interested that can't make this time slot or miss a particular week, or you've maybe missed the first couple talks, these are being recorded as long as Zoom doesn't mess up on us, and you can contact me. We actually have a website sponsored with Stanford Data Science for Sustainability hosting the videos from this series. So if you want to review what was discussed or are going to miss a particular week, we try to get those up in a timely fashion. As a reminder, we're grateful for the Bill Lane Center, Woods Institute, Precourt Institute, as well as Stanford Sustainability Data Science Center for the support of this series. We've got a ton of great speakers coming up, and that includes this week's speaker, Dr. Sam Heft-Neal, who is here with us. We're pleased to have him sharing some of his work today. Sam is a research scholar at the Center on Food Security and the Environment and a member of the Environmental Change and Human Outcomes Lab at Stanford. Sam has a background in both environmental economics, and his work examines environmental drivers on health around the world. His recent projects have focused on estimating health impacts from exposure to a variety of environmental stressors, including temperature, dust, and wildfire smoke. I've known Sam, I guess, a couple of years now, and he always has a lot of insights into the things we're trying to understand in wildfires. And I think you'll be really blown away by, I think, a creative look at sort of, finding the needles in the haystack to better understand some of the trends he will talk about today. And I hope you'll like his talk, and I hope you'll have some great questions for him at the end. So with that being said, I'll pass over control to Sam.
Great, thanks a lot, Derek. Share my screen. You guys seeing the full screen? Great.
Yes.
Okay, thanks a lot. Happy to be here today. I'm going to talk about a project I've been working on as part of the Stanford Earth Young Investigators program, where Stanford brings in high school students to work during the summer with Stanford researchers. And so Jenna Alsup and Prathmesh Sonawane are local high school students who worked on this project with me. And what we're looking at is construction and historical database of wildfire evacuation orders in California. And as I'll get into, this has proved to be quite a challenging exercise. So overall, we want to better understand impacts of wildfire. When I think about impacts, I think of kind of two distinct channels, one being what the fire actually burns, and that could be just burned area, buildings, burning structures, or it could be this second category where causing evacuation orders is going to have some impact on people, even if their homes or property never gets damaged. Just being forced to evacuate is an impact from the fire that can have some consequences. And then the second indirect channel where wildfire creates smoke, and then there's all these downstream impacts of smoke. But there's less work that's been done on this indirect, or this impact of how do fires cause evacuation orders and what are the impacts of evacuation orders. And so if we knew when and where evacuation orders were issued, I think there are a lot of interesting questions we could ask. We could look at the patterns of evacuation, just simple numbers like how many people were evacuated in 2020 are hard to come by. Who was evacuated, which groups are most and least impacted. I think you could also pair evacuation order data with a bunch of other data sources. For example, cell phone movement data to look at how do people actually respond when evacuation orders are issued. Do people respond to voluntary evacuation orders or do they ignore them? These are important questions for emergency response that I don't think we have a great understanding of. You can imagine also matching social media data, COVID data. There are a bunch of interesting questions that can be asked if we know when and where people are being evacuated. And then I think for a lot of work, for example, looking at downstream health impacts from smoke, we're often assigning the location of individuals based on where they live, but it would be really useful to know when there are evacuations so that we cannot assign people to places that have been evacuated. And so our goal is to build a database of wildfire evacuation orders in California that includes when and where evacuation orders are occurring, what type, whether they're warnings, voluntary or mandatory, and then which fire is causing the evacuation order so that we can come up with fire level statistics. So when we started this project, it seemed like a kind of a simple ask to me, but it turns out that the issue is quite complicated. So the first thing we did was we called a bunch of people at different counties and at CAL FIRE to try and understand exactly how wildfire evacuations work in California. So our first question was, who decides when there's an evacuation? And it turns out the answer is it depends. A lot of the time, it's going to be local fire agencies or CAL FIRE in consultation with sheriff's departments. So the fire, whoever's fighting the fire, and that depends on the jurisdiction, is going to make some assessment of where the risk is, and then they go to the law enforcement agencies and they tell the law enforcement agency, we think you should evacuate now. And then the evacuation is actually issued by the law enforcement agency and enforced as well. We looked a little bit at the legal area as well to see, are evacuation orders legally binding in terms of, can you be fined or jailed for not following an evacuation order? And our assessment was it's really unclear. There are not many cases where people are actually jailed for not following an evacuation order, but I think there is potential for people to be prosecuted for ignoring mandatory evacuation orders and then putting firefighters and others at risk because of their actions. But there's really limited comprehensive information on evacuations. The reasons are varied. One of the most important reasons is that they're carried out by a variety of agencies. So if you call people in different counties and ask how the evacuation orders were implemented, you call 5 different counties and you can get 5 different answers of exactly what the process is for determining evacuation orders. And so because of that, there's just no single source of information. Also, different agencies have different ways for issuing the orders. Some of them use NIXL, the emergency alert system. Some of them use social media. Some of them go on TV, Facebook, Twitter. It's really, again, varied, which makes it really hard to find all this information. And then one of the other big issues is that the geographies are really varied. So some counties have specific evacuation zones that are predetermined. These boundaries have been agreed upon, and then when evacuation orders are issued, you'll see, zone 2A is being evacuated now. And so everybody can look at the map and see what zone 2A corresponds to. But most of the time, that's not the case. And so as I'll show you in a little bit, what you get are essentially evacuation orders that reference landmarks, and you have to kind of back out what exactly regions are being referred to. In terms of existing work, there's this one report from 2020 that I think is the best source of information on evacuation orders. They did a great job. They surveyed about 500 people who had been evacuated from different wildfires. Then they had really detailed information about what happened, what were the impacts, where did they go, how did they respond. So that's really useful. And they did some kind of back of the envelope calculations about how many people were evacuated based on where fires occurred. But it's really hard to use their data to actually apply it to a more empirical analysis of evacuation orders. So this has been great background, but we couldn't find any real detailed empirical work looking at this. So what does an evacuation order actually look like? Here's an example of an LNU lightning complex evacuation order issued by the Sonoma County Sheriff's Office through NIXL, which is an emergency alert system. And so you can see on this date, August 18th, 2020, they're issuing an evacuation order. But what they tell you is that it's for the area immediately to the south of Stewart's Point, Skag Spring Road, north of Austin Creek, west of the intersection of Mill Creek Road, at Puccioni Road, and east of the Cedars. So what does that mean in terms of us actually creating a database of this? Well, we can go into Google Maps and we can see where those points are. And essentially they've given you 4 endpoints where you can draw some type of shape to determine where the evacuation order is. But ultimately we would love to automate this process, and we're finding that it's very difficult to do so because it's hard to go from that text to some shape that we can actually use and apply to spatial data. CAL FIRE also has evacuation order information for certain fires in the past. And so here's one example for the SU Lightning Complex incident. On their website, they have a bunch of evacuation orders. Fortunately, many of these counties have predefined evacuation zones. So zone 2A, there is a shape file that tells you the boundaries of that zone, and you can actually go look up what does zone 2A look like. But then when you actually read the details of the evacuation orders, well, within zone 2A, it's actually subsets of the zone that are being evacuated, not the entire zone. And so again, you end up with these east of Fire Perimeter to Mines Road and San Antonio Road within zone 2A in Santa Clara County was evacuated on this date. But again, it's really hard to know how to automate this process so that we can have a comprehensive data. Another challenge was figuring out what is the right unit of observation for our database. So you could imagine each observation is an individual evacuation order. So when an order is issued, we could have the start date, the end date, and some polygon associated with the boundaries of that evacuation order. You could also imagine assigning each observation to the location day, which is what we ended up doing, but you could imagine a location hour. And then assigning the boundaries, again, was one of the most complicated parts. We had to determine, should we create our own boundaries? So should we create our own polygons that correspond to these rough regions that sheriff agencies have determined should be evacuated? Or should we use some sort of existing boundaries? You could imagine counties where we just overlap the areas that are being evacuated on counties and then have our database at the county level or the census tract level. And then start and end dates are also complicated because, for example, one entire zone could be evacuated on the same date, but then different subsets of the zone can be cleared at different times. So just because one area has the same start date, it doesn't mean it has the same end date. When we were looking for data sources, we browsed everything we could think of, initially by calling people and by looking at what's online. CAL FIRE was helpful. They certainly have data for some fires. We were hoping that they would have information for every fire, but when we spoke to them, they said they don't, partly because a lot of fires are out of their jurisdiction. Other local fire agencies respond, and so they are not even involved in those evacuations. Other times they were involved, but especially before the last couple of years, they don't necessarily have comprehensive records of that. We looked at the state agencies that are responsible for emergency response. They have a lot of information on kind of preparation, but much less data on what's happened in the past. County agencies, for example, sheriff agencies have some information, but again, none of the ones we talked to had like a single spreadsheet of all the times they've evacuated people. They more had a general idea of which fires they'd evacuated people, but it wasn't organized in any way. We looked at searching Twitter for this information, but that was challenging partly because there's so much overlapping information and things change so quickly. It's also hard to determine. There's a lot of reports from news agencies, which we would presumably trust. But then there's also a lot of individuals who are just saying things about evacuations that may or may not be true. So we looked at only evaluating certified accounts, like from sheriff agencies, but even then, it was hard to get a comprehensive feed of information. NICSL, the Emergency Alert Service, is potentially helpful, but a lot of counties don't use it, and they were very unhelpful in wanting to allow us access to their data. And then online newspapers, you can kind of search them, but again, none of that individual newspaper is going to have a comprehensive database of everything that's happened. So in the end, we ended up developing a database where the unit of observation is census tract by day. So each row in our data frame is a census tract date, and then we will, for that census tract date, we have whether or not that census tract was under a warning, voluntary, or mandatory evacuation order on that date. And then if an evacuation order lasts for 2 weeks, then there'll be 14 observations for that census tract that are under evacuation. We overlapped the boundaries that the agencies issued on census tract boundaries, and we determined that if any overlap occurred, we were going to count that census tract as evacuated. Similarly, in terms of the date, if there was an evacuation order issued at 5 p.m., we consider that day evacuated. So there's going to be some noise, both in terms of the spatial boundaries and in terms of the timing, but this is what we settled on. For the exact steps, we first defined a sample of fires under consideration, which we took CAL FIRE's list of all fires over a certain size. And then we went through each of those fires and we searched for any information from any of the data sources previously discussed to try and figure out whether there are any evacuation orders. If there were no evacuation orders for that fire, then we assigned that fire 0 evacuation orders and we moved on to the next fire. When there were evacuation orders, then and by we, I mean the high school students that I work with, manually filled in the spreadsheet with the relevant information. So this was really tedious, but was much more effective than anything else we could come up with. And so they would list the fire name, the type of evacuation order, the start and end dates, and the census tracts that overlap evacuation orders. And they did this by going into Google Earth with maps of the census tracts, and then going essentially evacuation order by evacuation order, evaluating the boundaries that the evacuation order specified, and manually determining which census tracts were going to be within that area. So in doing so, we end up with a database where at first each row is associated with kind of a distinct set of information: one fire, one evacuation start date and end date, and then the counties, the source of information where the evacuation order came from, what type of evacuation order it was, and then some information that was provided on the region. This is just zooming in on the same thing. So for example, this one told us it was north of Austin Creek recreational area, east of Cedars, et cetera. And then from there, the students, my collaborators, assigned all of the census tract IDs that corresponded to any of the areas listed in the evacuation area. From there, we were able to reshape this data to get into the census tract by date framework that I had mentioned. So what can we do with this type of data? And I think this is where it starts to get a little more exciting. So for this summer, it took us a long time just to figure out how we wanted to try and do this. And we ended up doing it only for Fresno and Sonoma counties as sort of a test case. And so for now, we can evaluate what can we do with our data in Fresno and Sonoma counties. And so some examples of the types of things you can calculate. Well, between 2000 and 2020, there were 57 wildfires in Fresno County, and we estimate that 7 of those 57 had evacuation orders. And you can see the borders of the 7 fires that caused evacuation orders. We know the length of the evacuation orders, so we can calculate the average in each county. In Fresno, it was about 4 days people were evacuated. In Sonoma County, it was 6 days. One of the reasons that we wanted to do census tract is because it gave us information that we can easily link to population information. And so here we just looked at the number of evacuation orders by census tract. So this is from 2000 to present, how many times has each census tract been evacuated? And you can see in Sonoma County, the southern part of the county has never had any evacuation, but the western part has had 8 to 10, and the northern part has had maybe 16. In Fresno, you have this dynamic where in the foothills of the Sierra and in the western part of the county, you have had evacuations, and then in the Central Valley part of the county, you've basically had no evacuations. And so because of these patterns, and because we have population data that can easily be linked to the census tracts, then we can start to look at things like the number of people living in evacuated areas. And so, for example, we can look at the trends in the number of people living in evacuated census tracts over time. Now, because of the way we did this, assigning an evacuation order to a census tract anytime there's any overlap, then the wording I use is the number of people living in evacuated census tracts as opposed to the number of people evacuated, because we can't say for sure that these people are evacuated. We just know that some people in their census tracts were. And so you see there was no evacuations between 2000 and 2011 in Fresno County. And then 2012, we see a few in 15, 16. And then all of a sudden you see 2020 here, there was over 120,000 people living in evacuated areas, which is 5 or 6 times the highest of any other year. We can also start to look at socioeconomics. So when you do this, we start to see some interesting things because, for example, in Fresno, this is the income distribution of the overall population of Fresno County in terms of statewide income. So about 44% of Fresno County households are in the bottom quintile of income statewide. But when you look at the population that lives in the evacuated areas, well, we have 0% in the first or the fifth quintile. So essentially none of the lowest income and none of the highest income populations in Fresno County have ever been evacuated. All of the action is happening in the middle part of the distribution. The third quintile has by far the most part of the population. And if you think back to the maps of Sonoma or of Fresno County, I think that's because the lowest income residents are largely agricultural workers in the Central Valley, which is in the middle part of the county. And so you don't actually see evacuation orders in any of that part of the county. You see it much more in the foothills, which tend to be whiter and more middle income. Similarly, we looked at age distribution. So again, here for Fresno County, we have in gray the total population. So you can see that the total population skews young. There's a lot of people under 10 and under 30. But when we look at which populations were actually evacuated, it tends to skew older. A lot of people over 50 and even disproportionately high number of people over 70 and over 80. So again, the evacuated population is not a random subset of the total population. It's some subset based on where people choose to live. And it looks like in Fresno, at least, elderly people are more likely to be evacuated than non-elderly people. We also looked at the intersection of race and income. So here we have race or ethnicity on in columns, and then these are income quintiles in rows. So the top left is white households in the bottom in the first income quintile. This one would be Hispanic households in the highest income quintile. And again, we separated by total county and by evacuated population. And so for total county, we see that the biggest group in Fresno County is low income Hispanics. So in the first quintile, Hispanics. When you look at who's evacuated, we see again that it's this middle income white group that is the most likely to have been evacuated. And even the fourth quintile is also much more likely to be evacuated. And among the Hispanic population, it's actually the middle income Hispanic population that's more likely to be evacuated, whereas the low income Hispanic population is less likely. And so these are interesting patterns, and they're much different from what we see in a lot of other environmental hazards, where non-white and low income groups tend to be disproportionately affected. But at least in Fresno and Sonoma, we've been finding that it's much more middle and high income white households that are most likely to be impacted by evacuation orders. Another thing we can look at is English proficiency. So in Sonoma County, we know how many households don't speak English. And just looking at the areas that were evacuated, we estimate that about 9% of the evacuated households living in the evacuated census tracts don't speak English. So when you're thinking about policy responses to managing evacuations, it seems like at least in Sonoma, it's really important to have Spanish, which is by far the most popular language besides English, information on evacuations, because a full almost 10% of the evacuated group is going to be non-English speakers. And so if you want to have an effective system for getting people evacuated, it's going to need to expand beyond English. So to summarize, we think this is an interesting and important topic. We have a framework for creating a database. It requires a lot of manual work, but at least now we have kind of a systematic approach. There's going to be some imprecision around the dates and locations, but we think that as a first cut, this is a good start. We believe that the database will allow for interesting insights. As I mentioned earlier, I think one of the things we'd like to do is be able to have a data product that can easily be merged with other data sets. And so, for example, as I mentioned, the movement data, we would like to be able to just overlap on census tracts the number of people that are moving, so you can literally estimate what percentage of people follow, or what percentage of people don't move when there's an evacuation order in place. Similarly, for social media data, we have a bunch of data on sentiment from Twitter that is, an approximation of how happy people are. You would expect that people being evacuated makes them really unhappy, but it would be interesting to know how much unhappier are they when they're evacuated versus when there's a flood or when there's a big smoke impact. I mean, there are a bunch of different comparisons you can make, but you need to be able to have the spatial and temporal component to be able to assign essentially evacuation status over space and time. We were unable to automate the process, so most steps are manual. This has been a frustrating part of this project. We had brainstormed before we started with a bunch of people, many of the people in this group, on ways to automate the process. And we followed a lot of different threads, hoping that that would be possible. And we ultimately determined that it was not feasible. And so one of the nice things about the Stanford Earth Young Investigators program is that there's a great group of high school students who are very capable and very willing to do some of this tedious work to be part of research projects. And so I've been lucky to work with some great students, and they were able to kind of power through this, and also to create an outline for future students of exactly like tips on how you do this. And if other students want to come along, how would they pick up where the previous students left off and complete the database. And then ultimately, we would like to make this a publicly available data product. I envision it as something that's available to everyone, in part because I would love for people to give us feedback, to tell us that we messed things up for certain fires that they're studying. There's almost certainly going to be some errors in terms of how we're assigning locations specifically. And so if it's open to everybody and people are studying individual fires, which is what mostly how evacuation orders have been studied in the past, very limited for a very specific location and time period, then I'm hoping that we'll get some feedback. But I think that this product could be helpful for furthering wildfire research and using it as an input to a bunch of other types of work. That was only 30 minutes, but that's all I have. I would love to, if anybody has suggestions for ways to improve this or ways that this could be made more useful, I would love to hear them. We've done 2 counties. We hope to do the other 56 next summer with a new group of high school students. So now is a great time for us to revise and improve this data product before we actually take it all the way.
Well, that's great, Sam. Thank you so much for that presentation. And like I said, I think it's a great piece of work. You described it to me, I think, many months ago, and now I have a better picture of how nuanced and how complicated it was. But I'll open the floor to questions. I have some of my own, but I'll let you guys ask them some questions first. You got some questions from the audience or comments too, as well. Laura, go ahead.
Sorry. Okay, thank you for this. This was really interesting. I was wondering, is there any information available like after a fire and after everybody's returned about like whether the evacuation was necessary and whether there were people who should have been evacuated and weren't?
So that's a great question. I think that's the type of question that you could ask with these data by looking at where did the fire ultimately burn. Then if areas were not evacuated, but ended up really close to the final fire boundary, I think that would be really useful information to give back to the people who are determining whether to evacuate. And as you mentioned, maybe some people, I think because it's such a location-specific decision, my impression from talking to people is that there's very different levels of risk tolerance among the people making these decisions. And so I think some areas, they're much more likely to be cautious and issue evacuation orders early, and other areas, they're going to wait till the very last second and try not to evacuate unless they absolutely have to. But I think trying to quantify that is something that would be really interesting and would be useful to provide feedback again to the decision makers, because I don't think they can quantify that either, because they don't really have all the data to look at this comprehensively. From talking to people I know, like one of the people from CAL FIRE pointed out that the risk tolerance levels among the sheriff's agencies they work with really varies. And so they can make their recommendations, but people are going to respond however they want. They're not going to force any sheriff agency to issue an evacuation order. And so I think, yeah, looking at like evaluating essentially each department's effectiveness of issuing evacuation orders is something that we could do along the lines of your suggestion. I think that would be super interesting.
Great, thanks for that question, Laura. Other questions?
I would love for someone to tell me some really simple way to automate everything. That would be awesome.
Let me go to the chat here. I think we do have some comments here. Let's see. I'll go with Jill. I'm going to read it straight up. Thanks, Sam. Not exactly useful for database construction, but I have some survey data on Californians' experience with wildfire risk, and it might be useful for comparison when looking at evacuation by other demographic factors. That's a comment and an offer.
Oh yeah, thanks, Jill. That's exciting. I think it would be like, I think there has been some work. It sounds like along the lines of what Jill's done and some of the other work we've seen where people have studied individual fires or done surveys, and that type of work is so detailed that it's really insightful. And I think it would be really cool to combine that with what we're doing, which we're trying to make it more, statewide, kind of high level. But I think combining it with some of the really detailed individual level stuff could be really insightful.
And then Kate has a question here. She said, to piggyback on Laura's question, did you see any evacuation orders due to acute smoke impacts? Or were they just when areas were in the path of the fire?
Yeah, that's a great question. No, we saw no, at least in Fresno and Sonoma, we didn't see any, and none of the people we talked to who think about this were worried about evacuation for smoke. Everybody was worried about evacuation from buildings burning. But I think, should we consider evacuation orders for smoke is a good question. And I think with these data, we can combine it with smoke information to say, perhaps these are the places that should have been evacuated for smoke, even if there was no fire risk.
Yeah, it seems like, your ultimate product could be an amazing, I guess, data layer to couple with so many other things.
That's how we see it. Yeah, to let other people do, however they see fit. I think there are a lot of interesting questions to be asked with it.
Heather asked a question that I was sort of trying to figure out myself. So she asked, how are most evacuation orders communicated? By phone call, text, email, bullhorn?
Yeah, another good question. So a lot of it is door to door. They'll have firemen and sheriff officers and volunteers going door to door. A lot of it would be on social media, Twitter, Facebook, often the news as well. Nixle alerts that they can send to basically everyone who signed up mobile phones via text message is also a common format. But I think one of our takeaways was that there's no single way that if you talk to different agencies, they all have different approaches. So there's no single answer to this question. I think it's really agency specific. But in terms of the most, I would say that basically every agency now issues alerts on their social media accounts, which will be Facebook and Twitter, as well as most use Nixle, which again, I think is a sign-up service. I don't believe that we didn't see instances that, so there's also like the statewide alert system where sometimes, you'll get a notification on your phone about a child's been kidnapped or something. That one you don't sign up for, right? That's something that they can just send to everybody. I don't think that system gets used for wildfire evacuations very often, just because of what's allowed and not allowed to be pushed to that system as currently designed.
Yeah, I guess before we
go ahead.
Oh, I guess, yeah, that's exactly your comment there really has me thinking about why not, or is there some alternative layer or jurisdiction on that? Because it seems like in the case like a Paradise, right? Social media, unless you're on Twitter all the time, might not be fast enough. And it seems like, I guess one of my questions of many were, did you hear any feedback on how successful they felt these evacuation orders are? I mean, Laura asked about, you know, were they at risk or not? Were there cases where like, oh my gosh, we really should have had orders faster, or they just didn't get out there, and sadly that was tragic?
Yeah, I mean, we didn't hear too many stories like that. But following up on the earlier point, I do think in a case like Paradise or something where it's kind of very urgent, it will be door to door and bullhorn. Like there will literally be sheriffs going door to door and yell like on loudspeaker, telling people to evacuate and knocking on doors and assisting people who need help. That's the way that most agencies will do it when it's extremely urgent.
Okay.
But then that's hard for us to use as a data collection source.
Yeah.
But it makes sense that that's how they would implement it.
Yes, unless they have some sort of records. And I have some suggestions of the data, but I'll get to that later. Let's see, what do I have here? Felicity said, following up on Kate and Laura, does your demographic analysis on who was evacuated in Fresno indicate that higher income neighborhoods are far more likely to be evaluated?
Yeah, so
evacuated, not evaluated.
We didn't look at that question specifically. We just looked at kind of who's evacuated, and so we didn't see the highest income neighborhoods evacuated. But I think kind of what you're getting at is this question of whether or not all communities are treated equally in issuing an evacuation order. And I don't think we can do that with just looking at what we have now, but that's something we've talked about. And our idea was to essentially combine our data with demographic data with fire risk and with actual fire perimeters to see, because different like high income groups might be disproportionately located near or far to fires compared to other groups. But I think if you can condition on a group's fire risk and then see how likely they are to be evacuated, that would give us a better insight into whether there's kind of preferential treatment in evacuation orders, which we don't really know. But I think that's another really interesting question that we could examine if we had some information on kind of what's the true risk that each group is being faced, and then conditional on that risk, who is being evacuated first, or which groups are being evacuated and which groups are not. I'll say one thing that came up among the firemen that we talked to was kind of a frustration that like second homes in remote areas, being forced to go into areas that are kind of difficult to get to, where wealthy people have second homes, and then evacuating them, that was like a source of contention where they would rather people went to their first homes and were away from the dangerous areas and not causing them to kind of expend additional resources to protect these kind of homes that are in really dangerous fire areas that are kind of isolated away from everything. But that was just one individual's kind of remark to us.
I've actually heard, I guess, many anecdotes like that, talking to, like, I remember Santa Rosa firefighters came to give a lecture in Bruce Kane and Leonard O'Donnell's class, saying that, their first job is to protect life, but they'd like to honestly get that out of the way and then focus on the fires. But, their priority is to preserve human life. So if people don't obey evacuation orders or delay, that makes their problem even bigger, because they still want to save those people, but then they have to divert resources there as opposed to actually fighting the fires. So Heather has another question. If an evacuation order is made, are people allowed to enter the area to evacuate possessions, or is it an exit only strategy?
So when it's mandatory, it's exit only, and they do not allow people to re-enter until the evacuation has been cleared. When it's voluntary, then they discourage people from re-entering, but they allow it. And when it's a warning, again, they let people do what they want. But once it's mandatory, they will try to enforce people not re-entering to get possessions.
Right. Other questions? I don't want to go through all my list. Other questions from people? Either raise your hand or speak up. We have a small enough group here, or you can type it in chat.
Yeah, these are all really great questions and good potential research ideas. So this is great. Thank you.
I guess I'll go with one of mine. I guess this is more of a just really probably a hard to answer question, but did you get a feel from the different jurisdictions that they were happy with the way they conducted things? It seems like you have so many jurisdictions with so many methodologies and procedures. I mean, I know people don't like big government or huge infrastructure, but it seems like in this day and age of climate change and just regular wildfires, it seems like there should be something better in place, something more systematic and universal. And did you get the impression that people wanted that, or people were like, we do our own thing, when it's in our backyard, we do things our way, and then if not, other people can do things their way?
So I think there are two parts. I think there is a trend towards jurisdictions kind of making predefined evacuation zones and then assigning people to be responsible for those specific zones. And so you'll see, like in the last couple of years, a lot of these systems have popped up, and then counties will have websites where you can know what evacuation zone you're in. You can potentially sign up for alerts for that evacuation zone. And so I do think it's getting more organized. The part that people are sensitive to not having outside influence in is the decision of when to evacuate and when not to evacuate. I think that choice, which ultimately is usually made by the sheriff's department, the people we talk to, I think, would not appreciate like a universal rule for making that determination. They think they know what's best for their jurisdiction and don't really like outside influence in their decisions.
Yeah, I guess that makes sense. That's what I was asking. And I guess with regard to coming up with a system for zones, that seems like a big need, right? To have some sort of, that would be a nice universal thing, right? Your home, once you buy your home, it's like, by the way, you're in zone 62A. So
absolutely. And then somehow have a system where you don't have to opt in, like an opt out system to be notified, because a lot of people are not going to opt into these sign up lists. But I think you want to have everybody kind of by default who lives in an area that could potentially be evacuated have immediate alerts to their phone when there's an evacuation order. Although there's also a lot of people in some of the more rural areas who don't have mobile phones who also need to be evacuated.
Well, that's a good question about the mobile phones. I guess, yeah, if mobile phone service is not available, that's pretty challenging. And I was going to make a joke, but sort of seriously, if we don't opt into getting told about our extended warranty for our cars, I think I would gladly opt into hearing a fire alert. Jill, you have a question.
Yeah, thank you. Thanks, Sam. This is a really cool project with the high schoolers. I was curious if you could, if you think that this data could be useful if you can think of a way that like this could connect with understanding egress pathways and thinking about like, were we evacuating many additional people because we were like worried about the way they were actually going to evacuate, or like, was there a phased evacuation because of that? Or like, could we not evacuate as many people as we wanted because it was like hard to get out? So yeah, are there any like connections there you can see?
Yes, thanks, Jill. That's not something I've thought about, but that's really interesting. I guess you would want to have some kind of data on, so we don't observe where people go, but I think you can kind of, just from networks and geography in certain areas, you can kind of tell there's one direction to evacuate based on like away from the fire. So you could certainly evaluate like a level of connectedness and how that impacts when evacuation orders are issued. Yeah, that's an interesting question that I haven't thought enough about. But I think that's another type of research question that would be useful to know more about, and then to work with kind of the agencies issuing decisions to, maybe decisions are being made too late when there's only one evacuation route. Yeah, I'm not sure. That one sounds complicated, but super important. And if you have ideas, anybody who has ideas and projects they want to work on related to this, I would be happy to collaborate.
And I'll piggyback on that. Even if you've got a project idea related to this or otherwise, let me know, because we have our hackathon coming up next quarter. So some students will probably come with some creative solutions for things we haven't thought about. And that's why I want to bring Sam into the fold, because some of these data mining issues, I have a sense that students can figure out. I don't think I could do it, but I think there are some tools out there that could help out. Other questions?
Just to finalize that thought for maybe the course that you're teaching, Derek, is using some like optimal flow or like optimization type principles combined with data on where evacuations are happening. It could be really interesting.
Yeah. Kate, you have a question?
Yeah, this is sort of an observation more. I don't know if it would be interesting for the direction of your research. So Felicity and I were having a little side chat. I'm from Fresno, so I was kind of answering her question that my experience is that the wealthier communities in Fresno tend to be in town, whereas the foothills are more middle income. So I would anticipate that the more evacuations would be middle income. But I was telling her that there are a lot of like housing development in the foothills going up, particularly in Madera County. So that might be interesting to see as you build, like whether those kinds of things change over time.
Yeah, that's a great point. And I'm glad our results match kind of your intuition.
Yeah, for sure.
Awesome. Thanks, Kate. Bill, you have a question.
Yeah, just as some context, Paradise is my hometown since about the 1960s. And I'm also kind of a data guy. I've been talking to Google and stuff about that. One of the problems that the Google folks that did a lot of work up there identified is the emergency people didn't know where the people were that weren't evacuated. And one of the ideas that this person brainstormed is if you could even identify the houses that have cars in front of them, because people that are pretty senior, you can try to call them, they may or not answer. You can try to yell at them with first of all, a megaphone in Paradise isn't going to go too far. So you really might need to figure out some way to find the homes that are not evacuated, even if something's been announced. Just brainstorming.
That's a great point. I think that potentially goes into a recommendation for pre-emergency preparedness, is having some idea of where people are before a fire occurs, so that you can, at least like you said, developing a database of houses with cars in front, or however, some way to not just be searching blindly for people during an emergency.
Well, the Google people were actually suggesting looking for the cars during the fire, because if all the cars are missing from the front of a house, the people are probably evacuated. If there's a bunch of cars there, they might be. So it's something a little more dynamic, but
that would be interesting.
Just throwing an idea out that I heard from some smart people.
Yeah, that's really interesting. Thank you.
No, it's a great idea, Bill. It actually links to one of our previous hackathon projects where they actually used imagery. So you can imagine even drone imagery, right, of before and after. So I think what you suggested would work, right? If you have some information of before a fire and then you take dynamic image right around a fire beginning, you can have a before, after, and an AI driven comparison tool that would give some guidance to evacuation orders or searching, I guess.
The evacuation people evacuate the people that are still in the houses.
Yeah.
Just an idea.
No, great stuff. Other questions? These are great questions and many good ideas. And I'm taking some notes down here so I can contact you guys to also get you involved in our hackathon. Sam, I have one more question. So, and maybe it's too big of a one to answer. So I know you seemed like you pointed at a lot of bottlenecks that you didn't anticipate, and I really appreciate that. Those are real bottlenecks. What are the biggest bottlenecks? Maybe two of them right now that you felt that had to be manually done. So one of them seemed to be looking at evacuation orders themselves. Are these just text documents or web searches? Yeah,
so most evacuation orders do not have maps associated with them. Okay. They'll have some text that describes the area that's being evacuated. And so that makes it hard to, I mean, I guess you could take the text and probably develop a procedure for kind of manually drawing, shapes with those boundaries. That's not something we tried to do. But we were initially hoping that, like, in the places that have evacuation zones, we could just use these predefined boundaries. Like, okay, we know zone 2A is being evacuated here. We know what zone 2A is, and then use those boundaries. Drawing our own boundaries based on some vaguely defined perimeters is definitely one of the bottlenecks. That's the main thing we did manually. I guess the other one is just determining whether an individual fire has an evacuation order or not.
Okay.
Because most fires don't require evacuation, and there's no kind of database that tells you whether or not they are.
Well, we should talk, because I'm a pseudo data scientist, I'm an oceanographer, but I do think, at least theoretically, that this is something that could be automated.
Yeah.
Based on fact, what I've seen people do, like last hackathon for the late Iris Hoy, they scraped data from ballot measures, right, to extract. So smart people have done that. I haven't done it, but it seems possible for people to scrape the text and then go over to Google Earth and create those boundaries in an automated fashion. And maybe that could be a hackathon challenge project.
Yeah, that would be great. I guess the other issue is that there's no single feed of information that works for everywhere. So if like everything came through, Nixle or something, then that would be a nice way to automate it. But it seems like different counties release their information differently.
Yeah, so that's I think that's a hard one. I don't know how to crack, except again, do some machine learning. Okay, well, not machine learning, but do some automated. Each county, you have to look at these databases. So there's got to be some manual setup there. But
right,
maybe 20 years from now, there will be something easier. Other questions? We have a couple minutes left, but we're almost out of time. Any other questions or comments for Sam? Really enjoyed his talk and some great dialogue after.
Yeah, the questions have been great. I think in the end, it took the students, what did they estimate? It's like 6 or 7 hours per county of work to get everything. But it depends a lot how many evacuation orders are in a county. It's like 6 or 7 hours for Fresno, which had maybe 16 evacuation orders. I think or 16 fires with evacuation. I don't know off the top of my head, but that's like the order of magnitude we're talking about. So it's a lot of work, but potentially manually doable if you have a group of several high school students who are willing to work for, a summer.
That's nice. Well, I'm glad you have the resources for that. And yeah, it's a great program. So, well, if there aren't any other questions, I'd like to thank Sam again and thank you guys for participating in a very active way. We got some great comments here and some great questions. And again, things I want to follow up on for our hackathon. We're going to continue on Zoom, I think, for at least a week or two more. Next week, we have Jeff Maroka from the Lawrence Lab come to talk about simulations and fire predictions. So I encourage you to join us again next week and encourage your colleagues to come to join us for this discussion and dialogue. Have a great week, everybody. Stay safe, and we'll see you again next week. Take care.